Take it away, sir.
Okay. Thank you very much for coming. I hope you're not too sleepy after lunch, but hopefully I'll try to make it entertaining enough. So this slightly, if you feel like this workshop is a little bit, because this is like a talk/workshop, so it's very practical, as you will see. If you feel like this is a little bit rushed, there's also like a 1.5 hour recording that a little bit more calm down explanation of this. And yeah, all the slides, all the vulnerable apps that I'm going to demonstrate, and everything else, this is all available for free there. It's just service.com/free. So you can get it there if anybody's interested in, you can try this exercise on your own and all that stuff. So, okay, so today we're going to see how to hack JavaScript desktop applications with XSS and remote code execution. So I'll give you like a quick introduction. So if you have no idea about this, like how you can get started and so on. And then we will see some interesting scenarios about attacking Electron, right? So what XSS means in the context of a desktop application, how to turn XSS into remote code execution, attacking preload scripts, and then a very interesting scenario about getting code execution through exploiting some inter-process communication, right? So I'm Abraham Aranguren. I'm the CEO of Sovereign Security. We do pen tests, we do training. We've delivered training at Black Hat, Hacking the Box, and many other places. I do stuff with Cure 53. I was involved with version 1 as well. And then I wrote a course for Electron Security a while back called Practical Web Defense. I'm the founder and one of the project leaders of OWASP OWTF, so this is a completely free and open source OWASP flagship project. So if you type owtf.org in your browser, that takes you to the OWASP page. We have 2 students for the Google Summer of Code this summer, so hopefully it will be better afterwards. Yeah, that's my slide share. I was a developer first, then I switched to security. So if you are a developer or you're a pen tester, I got your back. I know the frustration on both sides, right? So. Yeah, so this is some pen test reports where we did some work on. So Smart Sheriff was an application mandated in the entire country of South Korea. So there's 2 free public pen test reports that you can download about it. So by law, every parent and child was forced to install this app. And the idea was to help parents be parents. So the parent would control during what times of the day the child can use the phone, what websites they can visit, what applications they can have installed, stuff like that. In theory, a nice idea to keep the children safe. In practice, horrible security implementation. So it was so bad that we even gave a talk about it, right? So if you search on YouTube for Smart Sheriff dumb idea, right? You can see a talk about it, and those are the slides as well. And then other stuff we did was with the Chinese police, Chinese government apps. So BXAQ is an application that the Chinese police install in your phone when you cross the border. So it grabs your contacts, your SMS messages, what applications you have installed and stuff like that, and then uploads everything to a police control server. iJob is more for the police officer to try to enter like some information manually, like blood type, height, power consumption, and other stuff like that. And then study degradation is an interesting concept where the application is not mandated in the entire country, as Smart Sheriff was in Korea, but it is encouraged in China. So the more you know about the great leader of China, the more points you get, and then with these points you can do some cool stuff, right? So I gave a talk about this at SECTI, so maybe some of you Swedish people were there or watched it. So that was Chinese police and cloud pets, so you can see a recording there. And there's a bunch of other public pen test reports, right? So this is all a quick way, to learn about security for free, just reading the public pen test reports of various companies, right? Now, the Electron course we have, and by extension, this workshop and talk was made more cool thanks to these 3 people. So shouts out to them. So Masato, if you have to follow him on Twitter. If you search on YouTube for Masato versus Microsoft Teams, he got at Kansas West, I think, $150,000 for a remote code execution. File descriptor, I'm not sure if he still is, but he has been for many years the #1 bug bounty hunter for Twitter. And then InsertScript has done a lot of cool PDF research and stuff, so they all helped make this presentation cooler. This would be if you want to take the course, but so I'll just skip through this. yeah, and this. Now, this sometimes we use these slides like to introduce the course and stuff. So I'll just talk about what we are going to be talking about today, right? So today we are going to see a bit of the web preferences, right? So how to set the security settings in Electron application, the package.json. We will see a bit of Electron XSS exploitation, how to exploit when node integration is enabled, and then some mitigation essentials. I'll also show electronegativity. From here, we will be attacking preload scripts. Then Electron applications, since they work on the desktop, they can also have like local leaks and stuff. So there's another stuff for that. There's stuff about man in the middle. Then repackaging is interesting, right? So another thing you can do with Electron applications is you can extract the application, then modify it as you wish, and then run it again, right? So this is a very interesting concept, and also much easier to do on Electron applications than on mobile applications where you have to normally install the application again. Then there's another one about instrumentation, so modifying the application at runtime, so you can achieve that with Frida and other tools. And then from here, we will be doing a bit of attacking Electron applications with file URLs and in Windows. So I'll show a demo about that in a second. You can also exfiltrate data, because when you have XSS on the desktop application, if the XSS is working from a file URL, in many cases you can retrieve local files and send them to an attacker. And then today we will have also a demo about this, IPC remote code execution. So I'll just talk about this later. Then there's defeating pinning and all the stuff. And then this is also interesting, right? Because we call this like hacking JavaScript desktop applications. So you're supposed to attack the desktop, but sometimes, and we found this in real pentest, you can have Electron components as part of a web application. And then suddenly all these attack techniques can actually serve you well to hack a web server, right? So that's an interesting concept, right? So there's a lab about that. And then there's another possibility would be local privilege escalation and stuff, right? So, okay, so with that out of the way, let's start let's pretend like you have no idea about Electron security. Where do you start, right? So first of all, why are people doing this, right? So a lot of security people are probably wondering, like, why risk it, right? Run JavaScript on the desktop if there's so many problems with XSS and so on, right? So the main reason is that normally you are going to have 3 developer teams, right? So this was the classic desktop application development. So you will have to pay Windows developers, Linux developers, Mac developers. This is expensive. It is 3 different development teams with different skills. They have to be coordinated. It's expensive, right? But with Electron, now you lower the bar to just JavaScript developers, right? Because there's more JavaScript developers, like let's say C# developers for Windows or Linux developers and so on, right? So it is easier to find JavaScript developers, so you have to pay them less. And also there's only one development team, so you only have to pay one development team instead of 3, right? So this is probably one of the top reasons why people are using Electron. And then the next question you might have is, well, who's actually doing this, right? So you can probably recognize some logos here, right? So Microsoft Teams, Skype, Zoom, Slack, Discord, Bitgarden, GitLab, Signal, and many others. So to understand these many of the attacks that I'm going to show, when you click on, for example, the Discord application, the first thing that happens, so let's pretend this is the Discord application, you click on it, the first thing that happens is that the main process starts, right? So main process, more privileged, can do more stuff, and then the main process, eventually, it will create a window with which the user will interact with, right? So this will be the render process, more exposed to the user. Normally, XSS is going to happen here. And with security settings, you can kind of, protect this a bit better. Here, if you have XSS here, you're pretty much done, because this has access to everything, right? But there's some mechanisms to lock this down, so we will go to about some of that today. So you have the operating system, right? So Windows, Mac, or Linux normally. Then the Electron core is going to abstract all that from the application, and it will interact through APIs with the operating system. And then there's the main process. The render process, they can talk to each other through IPC, which is a fancy way of saying they send JSON to each other, so inter-process communication. And then there's some API calls to Electron on both of them as well. So main process can do more stuff, more privileged. If you have XSS there, you're pretty much done. Renderer process, more exposed to the user, can do less stuff, but can be locked down a bit more. And also very important, this is all based on Node.js, right? So you have, well, I think I have another, okay, no. So you have the Google V8 engine that allows you to run JavaScript on a server, like with Node.js, but also on a desktop computer. Then on top of that, there's Node.js. On top of that, there's Electron. And then Electron will have these two types of processes, the main process and the renderer process. So if you have no idea, you have never seen an Electron application, where do you start, right? So one thing that you can do is download a very old application from the internet. So in this case, this is a standard Nodes version 2, which is very old. And then over time, there's going to be a lot of vulnerabilities discovered in the underlying packages. So you can download it and run npm audit. So the first time you run, so npm audit is here. So the first time you run npm audit, you might get this error message. The error message tells you what you need to do. So when you get this, is because you can have a dependency that has a dependency that has a dependency. So the tree of dependencies has to be resolved first. And then this will create this package log only file. And then you can run npm audit, and then you will get like some vulnerabilities with this, right? So then for, let me drink something. Another thing you can do is to find vulnerabilities in the configuration. So for this exercise, we'll use the vulnerable one application. If you try wget, it won't work. But again, if you go to cybersecurity.com/free, you can get access to all this, and then you can download the app from there and try this on your own later on. So the first thing to do is to look at package.json, and this will have a main entry point. In this case, the main entry point is main.js, and you can see here that we have web preferences. So node integration is set to true, which is bad, and context isolation is set to false, which is also bad. So why are these things bad? If node integration is enabled, the impact of any XSS is immediately code execution, right? So I'll demonstrate this in a moment. And when context isolation is disabled, this means we can mess. The JavaScript is running in the same context. The JavaScript on the user HTML is running in the same context as the JavaScript of the application. So with an XSS, you can kind of mess with the application. So I'll demonstrate this later on, and it will make more sense then. Does anybody see a problem with this code? Any takers, guessers? Okay, so we have a user input assignment. There's the message, and it's assigned to inner HTML. So we have DOM XSS vulnerability. Now, if you are interested on this, there's a DOM XSS wiki that lists all the sinks as sources, right? So sink is a place in JavaScript where if you assign user input there, you're going to get DOM XSS, and source would be where user input comes from, right? So location, hash, and other places like that. Okay, so very good. Then another thing you can do is to run electronegativity, right? So this will check. So the first thing to do is npm install add.onsec, which is the company that maintains this electronegativity, and then you have to use the -g at the end to install this globally, and then this will look for vulnerabilities in Electron configuration and so on, and here you will get like some results like with the affected files and the lines and so on, right? So in this case, you can see the problem is on main.js. These are the affected lines, so between line 7 and line 21. Here you have a link to read more about it, and then there's like some preliminary severity there. So let's do a demo about this. You can see this, yes. Okay, so I'm just going to run npm audit, right? So this is just, you just do npm audit on standard nodes, and you can see here, like we get some findings, right? So 4 low, moderate, 18 high, 8 critical. So this is because it's a very old version. So this will happen with any application. Then for the configuration, the first thing to do is to look at package.json. So I'm going here for the main entry point. You can see that this is main.js is in this case the main entry point. So then I can go into main.js. And here we can see node integration is set to true, which is bad. And context isolation is set to false, which is bad, right? Then on the render.js, we have the vulnerabilities. So this would be the vulnerable code where user input is assigned to inner HTML, and this would be a proper way to fix it, right? So I'll elaborate more about this in a second on the slides. And then electronegativity, you just run it like this. So you pass it the directory where the application has been extracted. In this case, it's vulnerable 1. So now you can see that you get like all the results pretty quick, right? Okay, so now let's make this more interesting and start hacking stuff. So what does XSS mean in the context of a desktop application, and how to turn XSS into code execution, right? So for this, we will keep using the vulnerable 1 application. Now, since we have to run it, I told you like Electron applications are based on Node.js and so on. So the zip only has the Electron source code. So you have to do npm install first, and this will install Electron, Node.js, and so on locally on the directory. And only then you can do npm start. And then the application will run just fine, right? Now, another trick that you can do against Electron applications is use these keyboard combinations. So the developers can disable this, but most of the time they don't. So if you do Control-Shift-I or Command-Shift-I if you have a Mac, this will open the developer tools, and then you can kind of like debug what's going on, if they are output encoding correctly, and so on, right? Now, if you come from a web security background, you might attempt like some payloads like this, right? Script alert 1 and so on. And in this case, in this particular application, you will notice this doesn't work. However, in the developer tools, you can see that the injection was successful. It's just the alert is not running. So this is expected. This is according to the RFC. If the page has already been rendered, the script is not meant to be executed. However, we can get around this with just an image. So you just put like a broken image, and then with the error handler, we can get the alert working, right? So we got alert 1, which is nice, but we can do more with this, right? Since node integration is enabled, I told you any XSS will be immediate code execution, right? So what we can do, and you can copy this from this link, these payloads. So what we can do is invoke any Node.js module. So there's Node.js modules that allow us to run operating system commands like require child process. So this would be the Node.js module. And then there's exec sync. Now you always want to shoot for the synchronous functions so that the function finishes and then you get the result and then you get it back in the alert. Because if you don't use the sync function, sometimes what happens is your code execution is working, but because of the asynchronous nature, you don't get the result back, so it's kind of weird. Yeah, so then you can try this, and then you can see here, like you can run any operating system command you want, but you're not limited to just running operating system commands. You can also load other modules, for example, to interact with the file system, read local files, and so on. Then for the developers out there or the penetration testers that want to provide proper mitigation recommendations in their pentest reports, let's talk a little bit about how to mitigate this, right? So you should always view security as like a little bit like an onion, right? As you should have like several layers of security, right? So one layer of security would be to disable node integration. So this will reduce the impact from direct code execution to just alert 1, right? So you reduce the impact a little bit. And when you do this, you will notice that you get this error. Require is not defined. You can no longer load Node.js modules, right? So this is why you get this error message. So this is kind of the first layer that you could implement. Then, of course, we still have XSS, right? So if you try alert 1, the alert 1 will still work. And then what you can do is implement some content security policy to, make it a little bit tougher for XSS to happen, right? So this is going to, in case you forget some XSS somewhere, this will make it more difficult and hopefully unexploitable, right? So that's the hope. And then you do npm start again. So you close the application, then run npm start again. And when you try this, you will see this error message, right? Refuse to execute inline event handler because it violates the following content security policy directive, and so on, right? So this would be another layer, but we still have an XSS, right? So you also should add another layer of defense, which would be fixing the XSS, which is actually the most important thing. So the best way would be to avoid the DOM XSS sync. So instead of using inner HTML, use text content. And then when you try this again, you will see in the developer tools that the HTML characters have been like encoded correctly, and this is displayed as text. So this is solved. But what happens if you have some rich text editor and you want to allow some HTML tags and so on? So in those cases, you should use like a well-hammered library that for sanitization. So Purify is a good choice for this. So you can install Purify like npm install Purify on the directory of the app. This will add it as a dependency. And then you just load it. And here you just do inner HTML. But you do Purify of sanitized message. Now, a better way would be here to add a whitelist of the HTML tags you want to allow. So, for example, only allow underline, bold, and so on. And this would be even tougher to bypass. And then when you try this, you try some XSS payloads, you will see that, the image source X and so on is there. So you still have the injection because you're allowing some HTML, but the on error and so on, all the JavaScript stuff has been removed, right? So let's do a quick demo about this before we start to complicate things. So I'm running here the vulnerable 1 application. I'll try to make this a bit bigger. View. Can you read this? Yeah, it's visible, right? Okay, so I'm just going to try not that. I'm just going to try the Linux payloads because I'm in Linux. So I'm sending these payloads at once, right? So this is the output of uname-a. Then now this one is taking longer, so this is the genome calculator. Then, let's see, where's my mouse? Then, because the genome calculator doesn't return anything, you get a blank alert. This is the output of the ID command. And this is the output of the ls command, right? So basically, you can run any command you want. But as I said, you could require, instead of require child process, you could require FS, or you could require other Node.js modules and do other stuff. But most of the time, people are going to use this just because, it's just easier to demonstrate. Okay, so this shows you a bit, the problem of having node integration enabled. And what we will be talking about now is how to attack preload scripts, right? So for this, I'm going to start booting my Windows VM. I think it's this one. So now for this one, we will be using the vulnerable 2 application. And this is what happens, right? So when context isolation is set to false, the preload script runs in the same context as the Electron application. So if the preload script has window ABC equals 1 to 3, and you alert the window ABC is going to be 1 to 3 on the XSS. And when context isolation is set to true, then this will return undefined, right? So this is why it provides better security, because basically you cannot mess with the preload script. So I think I'm going to show this in the demo, but basically the idea of this is with an XSS, we can redefine a function, right? So we will be redefining how the index of function works in JavaScript, and then this will allow us to bypass a security check. So I'll just show it directly in the demo. And yeah, the slides are more like if you want to try it on your own. So let me just jump to this. Hopefully, yeah. This is visible. Yeah, because I think if I show it in the slides, it's not as easily understood as in the demo. Like when you see it live moving, it makes more sense, right? So the problem is with the lack of context isolation, the XSS is running in the same context. The JavaScript is running in the same context as the application. So we can do interesting things with that, right? So I'm just going to start a vulnerable application. And this is like a messaging application. Now it has been simplified for ease of debugging and so on. But in theory, this would be like one user sending a message to another, right? So you send somebody else a message like, hey, look at this. Now the application linkifies the message. And then this is a very risky URL, right? So this is a file URL from a network location. This would be like attacker.com in a real attack. And then you have a Java extension, which will execute without warnings in Windows, right? So this would be remote code execution if it's opened in Windows, right? So when I click on this, the application says this link is unsafe because it is very unsafe, right? So the application is blocking this correctly. And now the way the application is doing this is here it is defining a safe protocols array. So I'm just going to break down the logic of the application in the developer tools so that you understand how this is working, right? So we have an array, position 0 is HTTP, position 1 is HTTPS. And then there's this check, right? So there's an event listener for clicks, and then if it is an href and so on, and then here there's this check, right? So the safe protocols index of different than -1, and if it is different than -1, so it is basically a safe protocol, then it will be sent to shell open external. So what shell open external does is it's going to send the link to the operating system. So if the link is HTTP or HTTPS, the operating system will open the browser. So this is safe. I mean, HTTP is not very safe, but at least it will not be code execution. So it is safe in that sense. And then if this fails, then is when we are getting this error message that this link is unsafe, right? So if I do safe protocols index off, and I put this here, and I do index of HTTPS, it is position 1. If I do HTTP, it's position 0. And if I do file, so I put here file, you can see that this is -1, right? So this is why when I click on this, the application is saying this link is unsafe. Now, since we have XSS in this application, what we can do is redefine how the index of function works, right? By sending, hey, look at this, but at the same time, we're sending this payload using JavaScript, right? So we're sending an image, and then this is redefining how the index of function works in JavaScript. So we are inverting the logic of the application. So I send the message, you can see the broken image here, and now if I do safe protocols index of file, it's going to be lit, right? If I do HTTP, it's also lit, and if I do HTTPS, it's also lit, right? So regardless of what you try, it's always going to be lit. So this alters the flow of the application, so you will never fall into this link is unsafe anymore, and everything will be open in shell open external. So now if I go ahead and click on this link, you can see that we are getting the code execution, right? So this is like the result of running that Java file. So we have code execution without warnings in Windows, which is pretty cool, right? And then hopefully I have time for the last demo. So now we're going to see remote code execution through IPC. So for this one, we will be using the vulnerable 3 application. So this attack requires several things, right? So we need an XSS on the application. We need the main process, which I told you is more privileged, can do more stuff, and so on, to do something dangerous, right? So it is listening for a get update event, and then it will basically try to get the update. And then the renderer process on preload.js is doing also something dangerous, which is expose an Electron API, right? So we have Electron send, and then there's IPC render send, and so on, right? So this is exposing an Electron API to the DOM, right? So if we have an XSS, we can now call directly Electron send, and then we are calling an Electron API because the application has incorrectly or insecurely exposed this. So what we can do is just send a script of Electron send get update, and then we provide a URL that has basically a Linux reverse shell so that we get code execution on the application, right? Other possibilities could be Electron open in browser, calling shell open external. So this type of vulnerability could happen in many different ways, right? So as long as the preload script, in this case preload.js, does something dangerous like exposing an Electron API like that, then you could call it from JavaScript directly. Electron listen, Electron send, so this could be other potential scenarios. And yeah, basically here, I'm just going to jump to the explanation. So here we have the main process. It's listening for get update. Then it will retrieve the URL. So Now in JavaScript, everything is event-based. So there's the event for will download, then there's the event for it's done, and so on, right? So will download, downloads the file. Eventually, it is saved into the downloads directory, and then it's given executable permissions, and it will just run it because it's an update that you're supposed to run, right? So yeah, and then so this is the script, just Electron send of this, and here we have like a Linux like one-liner. So it's basically removing a temporary file. Then it creates an input-output file on /tmpf, which is normally a directory where the server, or in this case, the desktop application, will probably have write permissions. And then you just cut the file, pipe it to sh. With interactive mode, you want to redirect error messages to standard output so that you can see that. And then you pipe this using netcat to the attacker.com, port 444, which is the official port for shells. And then you just send this to the temporary file, right? So. And then on the netcat window, you will get the shell. So let me maybe just jump to the demo. And then when you use console log, it will show on the terminal where you're running the application from. But I'll show this on the demo now. And then on the netcat screen, you should be able to get the shell and run all the commands and stuff. So let's just jump to the demo. So I'm just running the vulnerable 3 application. Let's make it a bit bigger. And now I'm just going to send this Linux reverse shell. So you would basically send this to the victim user, right? So in this case, so that we don't have infrastructure, it appears here. And now before I click on this, I need to make sure I'm running netcat, right? So I'm just running netcat here. So now if I click on this, and now I go in here, you can see that I received a connection. So I can run here like any commands I want. So yeah, cat etc password. Let's see if I can type. And so on, right? So what happened here? So if we look at the source code, right? So you can see here like main.js is complete. So I can go here to the source code, main.js. So I can search for complete. Main.js is complete. This is what's happening before, right? So main.js is complete. And then here you have like get update is called with this URL. This is the downloads directory. So it gets the URL for the update. It downloads it. And then you have like the receive byte and eventually download successful running update. So I can just jump for the running update, for example. And you can see it here where like permissions have been assigned and it runs the update and so on. Yeah, I have no idea how I'm doing on time, but I believe we have some time for questions. So again, if anybody's interested on the free stuff, there's the slides here, the vulnerable apps to practice with, and there's also a recording. And if anybody is considering the paid stuff, there's a June 50 discount that you can use now for 50% off anything on the store7security.com, if anybody was interested in that. And with that, we have time for questions, I believe.
Yep. Questions? Oh shit, that was hot. That was loud. Questions, anyone? No? Yeah, you have questions. Come on. Someone. No? Of course you do. So yeah, good.
Is it common to see those two configurations?
The most common would be the lack of context isolation. So Electron in 2019 changed the default of node integration to false by default. So this was turned, so until 2019 it was like on by default, right? So any XSS would be directly code execution unless the developer manually changed this. And then they changed the default, so this is now less common. But it will still be common in old Electron applications that have not been updated. But the lack of context isolation is still rampant because it's the default, right? So, and another technique that I didn't show is when there's no context isolation, and this is probably how Masato got Microsoft Teams. Well, another thing you can do is send an IPC to Electron itself with this hackery stuff. Like you saw how I redefined the index of function to attack the preload script, right? So that is one of the techniques that you can use. But another technique that you can use is to mess with the JavaScript code in Electron itself, right? So you can like do some hackery stuff and redefine like some bind and other JavaScript methods, and then you can send an IPC to Electron itself. But that's more complicated. We explain that in the course itself. But yeah, that is probably how Masato got Microsoft Teams, because it's the easiest thing to try, right? So the lack of context isolation, if you see it, that should be remote code execution given enough time, until you get like the proof of concept working, which requires a little bit of skill, but it is possible because you can always mess with the code, the JavaScript code of Electron itself, right? So lack of context isolation, I would say, would be the most common issue, and definitely can be always code execution if you know how to attack it.
Anyone else? Then I have a question.
Okay.
So how common is it that is it common that people implement DOM Purifier in their apps as well?
I think they have like 1 million something downloads, right? That
Yeah.
said.
But would you say that is common? Like
No, maybe in web applications, but
Yeah.
not in Electron. In Electron, this would be rare.
Yeah.
Yeah, but in web applications sometimes we see it, but not not too much. It should be used more often. At Nullcom Berlin, Freddy was talking about that they are planning to implement a sanitizer in the browser itself. So there's an RFC going on about this. So kind of trying to do like the DOM Purify thing at the browser level. So when they do that, there's already like a work in progress implementation. Then this will also be available in Electron apps because Electron is basically running Chrome, right? So whatever they do in the Chrome browser will eventually like make it to Electron as well. So yeah. So then from an Electron application, you could use the browser sanitizer as well as DOM Purify, right? So DOM Purify will be an external dependency, but yeah, this is already an RFC and there's already a work in progress implementation about it.
So anyone who dares to ask a question? It's very scary. No? No? Anyone? Oh, you can, yeah, I guess you are open for questions later as well,
Yeah,
if you're shy.
grab me
Okay, but
anytime.
without further ado, thank you, Abe, for the presentation.
Thank you.